Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. By the end of it, you should be able to understand and use this formula here, which gives you the general term of an AP. The idea is, you know A, which is the first term, you know D, the common difference, because all APs have a common difference, and if you substitute in a value of n, you'll find that number term. But firstly, why is this the formula? A lot of people get confused. Why is it n minus 1 when we're finding Tn? Well, this is what an arithmetic sequence looks like. So we start with some number a. We're just going to let a be the first term. So the next term of this sequence will be a plus some common difference. So then the next term after that, we take our previous term and we add the common difference again. Of course, I can make this easier by just writing it as a plus 2d. So that will be the third term. So the fourth term, you guessed it, I take a plus 2d and I add another lot of the common difference, then a plus 4d, and so on. This is an arithmetic sequence because each term differs from the previous term by d, whatever the common difference is. So this is T1. You can see T2 has one lot of d. You can see T3 has two lots of d. T4 has three lots of d, and so on. That's why we get the n minus 1d. If n is 5, there's 4 lots of d. If n is 3, there's 2 lots of d. So that is why this formula works. So let's look now at using it. So let's start by writing the first four terms of an AP with a equal 5 and d equal minus 2. So a is the first term. The next term will be 5 plus minus 2, which is 3. Then 3 plus minus 2 is 1, and so on. They are the first four terms. So this formula becomes a lot more simple when we have to find a higher number of terms, like the 30th term. So let's say I have the AP 19, 12, 5, and so on. This is an AP because each term is decreasing by 7. Each term is 7 less than the previous term. So it would take me forever if I were to go, minus 2, minus 9, minus 16. It takes too long. So instead, I'm going to use the formula up here. Tn equals a plus n minus 1d. If I'm finding the 30th term, I'm finding T30. So I'm just going to take my formula and I'm going to change n to 30. Now from this sequence here, a, which is the first term, is just 19. So I'm going to rub out a and change it to 19. Now each term is 7 less than the previous. In other words, if I have a term, I need to subtract 7 to get the next term. The common difference here is therefore minus 7. That's the difference between each term. So I'm changing d to minus 7. So T30 is just 19 plus 29 times minus 7. And you can use your calculator for this. It just equals minus 184. That is much, much faster than if I were to just write out 30 terms. So we can also use this formula to find a, or to find d, or to find n. Let's look at an example now where we're using this formula to find n. So let's consider this question. We have the arithmetic sequence minus 26, minus 7, 12, 31. Would 183 be a term of this sequence? So this is an arithmetic progression, an AP, because there's a common difference of 19. We're going up by 19 each time. Now, it's a lot easier to use the formula and solve for n rather than just keep adding 19 each time and see if we hit 183. So this is how we do it. So the formula we have is Tn equals a plus n minus 1d. Well, we know clearly a is minus 26. It's just the first term. And here d is positive 19. It's positive because we're going up each time. So we want to know, is 183 one of these values for Tn? So this is what we're going to do. We're going to sub in 183 and find the value of n. Remember, n always has to be a whole number. You can have a first, second, third, fourth term. You can't have the 4.2 fifth term or the 6.5 term. It doesn't make sense. So 183 will be a term of this sequence if and only if I get a whole number answer for n. So let's try and solve this equation. Well, let's start by adding 26 to both sides. So I get 209 equals n minus 1 times 19. So dividing each side by 19 and then adding 1 to both sides, I do in fact get a whole number for n. What I've actually found is that 183 is the 12th term of this sequence. So this is how we can use the formula to solve for n. So let's try this question here. What would be the value of t40? That is, what's the value of the 40th term if in the sequence the 5th term is 9 and the 21st term is 121. So what I want to do is use the formula Tn equals a plus n minus 1d. So if I want to find t of 40, well, I know that n is 40, but I don't know a and d. I need to know them to use the formula. So what I'm going to do is I'm going to use this formula twice, actually, to first find a and d. So I know T5 is equal to 9. So T5 of any arithmetic sequence is equal to A plus n minus 1. So n is 5, n minus 1 is 4, A plus 4D. And I'm told that equals 9. So we're also told T21, well, of any arithmetic sequence, T21 is A plus n is 21 minus 1D. A plus 20D is equal to 121. So now I have two equations with two unknowns. I can use simultaneous equations to find a and d. What I'm going to do is I'm going to subtract the bottom equation from the top to eliminate the a's. So if I do that, a minus a, of course, just gives you 0. 4d minus 20d gives you minus 16d. And then 9 minus 121, of course, gives us minus 112. Dividing each side by negative 16, we get d is 7. The common difference of this arithmetic sequence is 7. Now, we need to know the first term as well in order to use this formula. So to find that, I'm going to substitute d equals 7 into this equation here. So I get a plus 4 times d, 4 times 7 equals 9. Subtract 28 from both sides. So a is minus 19. So this sequence has first term minus 19 and goes up by 7 each time. So it goes like this. And you can see here the 5th term is 9. So to find the 40th term, well, that's really easy now. T40 is just going to be a plus n minus 1, so n minus 1 will be 39 times d, which gives us 254. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.